Welcome to The Explainer. We're always talking about making our computers faster, but have you ever stopped to wonder what really makes them tick? Today, we're going to peek under the hood and look at the secret ingredient, these tiny, unbelievably fast components called CPA registers. They are the unsung heroes of performance. But before we dive in, let me ask you a question. If you had to guess, what is the absolute, hands-down, fastest piece of memory in your entire computer? You might think it's your RAM, or maybe that super fast SSD drive, right? Well, take a guess. The answer, and really the whole reason we're here today, is something called a register. These are microscopic memory spots located directly on the CPU chip itself. They are, without a doubt, the processor's personal lightning-fast workspace. To really get a feel for this, let's use an analogy. Picture the CPU as a master chef in a super high-end kitchen. Okay, so the registers, that's the chef's own personal cutting board. Whatever ingredients they're chopping up right this second are right there, instantly accessible. The cache memory is like the prep counter right next to them. Close, but not right there. And the main memory, your RAM, that's the big pantry down the hall. Getting something from the cutting board is instant, but walking all the way to the pantry, well, that takes a whole lot more time. So here's what we've got on the menu for today. We're going to start with the two big families of registers. Then we'll check out the programmer's personal toolkit, and after that, the CPU's own hidden control panel. We'll even look at its personal status board, and then wrap it all up with why this whole setup is the real secret to a blazing fast computer.
All right, let's jump right in. At the highest level, all registers are split into two main families, and the big difference between them really just boils down to one simple question: who gets to see them and who gets to use them?
And here's where that difference really comes to life. The user-visible registers are like the ingredients our chef can physically touch, move around, and work with. But the control and status registers? Nope. That's the chef's internal plan. It's the timers going off in their head, the sense of how hot the oven is. The programmer can't touch this stuff. It's all automated, just part of how the CPU runs the kitchen. Okay, so let's dig into that first family, the user-visible ones. These are the actual tools that a low-level programmer gets to work with, all designed to keep the most important stuff right there on the cutting board. First up, you've got your general-purpose registers. Honestly, just think of these as the Swiss Army knives of the CPU. They're the super flexible workhorses that can hold pretty much anything you need at the moment. Data, a memory address, the result of a quick calculation, you name it. Then we have data registers. Now, unlike those do-everything general-purpose ones, these guys are specialists. They have one job and one job only: holding the actual data. The numbers and characters that your program is currently working on. And as the name kind of gives away, you also have address registers. These are all about location, location, location. They don't hold the data itself, they hold the address of the data. They're like little GPS units telling the CPU exactly where to go in that big pantry to find the right ingredient. And these address registers get even more specialized. You have things like a segment pointer, which marks the start of a whole neighborhood in memory, or a stack pointer, which acts like a little bookmark, always pointing to the very last thing you put down in a temporary scratchpad area. So now let's flip the coin and look at the other side, the registers that are totally hidden from the programmer. These are the ones that are absolutely crucial for making the CPU work at all. This is the processor's own private control panel. Yeah, you can really think of these registers as the CPU's own little brain or its mission control center. They're the ones managing the entire show, orchestrating every single tiny step of a program, fetching the next command, figuring out what it means, and then making it happen, all behind the scenes with zero input from the program itself. And this right here, this is the heartbeat of the CPU. It's this constant four-step dance that happens billions of times a second. See, it all starts with the program counter, which always knows the address of the next instruction. So the CPU fetches that instruction and puts it in the instruction register to figure out what to do. Then the MAR and MBR act like the loading dock crew, handling the actual pickup and drop-off of data from memory. And as soon as it's done, the cycle starts all over again. It's incredible. Okay, so inside that secret group of control registers, there's one that's a real VIP. It's called the program status word, or PSW for short. You can think of it as the CPU's master status board. So what's on this board? Well, it's not data. It's something called flags. And you can literally just picture them as a dashboard full of tiny little indicator lights. After every single calculation the CPU does, a few of these lights will blink on or off, giving the CPU instant feedback on exactly what just happened. And these little flags are what give the CPU its smarts. It's how it can check its own work and make decisions. Was the result of that last addition a negative number? Boom, the sign flag flips on. Did the result end up being exactly 0? The 0 flag gets set. Did the number get way too big for it to handle? That's an overflow. This is how the CPU knows if things went right or wrong, and what it should probably do next. Okay, so we've looked at all these different types of registers, general purpose ones, address registers, the program counter, all these status flags. But why? Why this incredibly specific, kind of complex organization? Why is everything set up exactly this way? Well, it all comes back to our chef. Think about it. A perfectly organized kitchen where every knife, every ingredient has its own dedicated spot, right where you need it. That's what allows a chef to work with blinding speed and efficiency. The CPU is exactly the same. This careful, deliberate organization is the entire secret to its performance. It's all about minimizing those slow, costly trips to the main memory pantry and keeping the processor working at full tilt. So, this whole intricate dance is what makes your computer feel snappy and responsive. But that leaves us with one last kind of strange question, doesn't it? If these registers are so unbelievably fast and so important for performance, why on earth are they so tiny, and why are there so few of them? And the answer to that gets into a really fascinating trade-offs between speed, money, and the actual laws of physics.